if there was an x-axis asymptote for exponential functions, for log functions, that'll be y-axis. If exponential function parent graphs contain the point 0, 1, then log graphs are going to contain 1, 0. So like I said, if the x-axis was an asymptote of exponential, then the y-axis is going to be an asymptote for a log graph. Did I talk about domain and range yesterday with the exponential graphs? Yes or no? It was on the homework. So the domain for exponentials is all real numbers. The range is that y has to be greater than 0. For a log function, that's flip-flop. The domain is that x has to be greater than 0. And the range is all real numbers. Right? Domains and ranges get flipped with inverses. Asymptotes get flipped. Points get flipped. X-intercepts get flipped with y-intercepts. So here's what the parent graph looks like. Log with some base. That base is like the base was to your exponential function yesterday. Yesterday was y equals b to the x power. And this is what the log parent graph would look like. Anytime, and we'll talk about this a lot, we translate log language into exponential language. So the log language is like French to us. It's not familiar to us. We don't really know what that means unless we translate it to exponential, which is the base of b raised to the other side as an exponent equals whatever you're taking the log of. So there it is, the base of b raised to whatever's on the other side of the equation equals whatever you're taking the log of. And if you compare this, which those are equivalent, this is just a foreign language, this is just what we can make sense of. This, compared to the exponential, obviously yet again, the x's and y's are switched, right? That's how you write an inverse. You switch the x's and the y's, and you solve for y. Couple things, your base has to be greater than 0. That was no different yesterday with exponentials. Why can't you have a base in an exponential? It's a negative number. What would that graph look like if it was a negative 2 raised to the x power? Aiden? The product, you said? Is that what you said, the product? So like this? No, that would happen if you put a negative out in front. Like a negative b to the x. I'm talking, what if b itself is a negative number, like negative 2 in parentheses to the x power? What would be the problem with something like that if your base wasn't greater than 0? Dots everywhere, exactly. So every time you plug in a new x value, the next integer up, it keeps flip-flopping from a positive to a negative. So if I were to look at that table, oops, I'm going the wrong way. 0, 1, but then when you do negative 2 to the first power, it's a negative number. Then it's a positive, then it's a negative. So it would keep flip-flopping back and forth. And I don't even know what happens if you try to graph this. Nothing happened. So So either the calculator's confused, or I'm just gonna go with that. The calculator's confused. You can't have a base that's negative. Why does your base have to be greater than 0? Why can't your base be 0? Mackenzie? Correct. No. 0. That's just a line. That's just a horizontal line. It actually does have a hole somewhere, though. Any ideas where? Because that's just going to give you y equals 0 for all x values except, Aiden? 0. Did you know that 0 to the 0 power is undefined? Did you know that? Now you do. So if I were to graph y equals 0 to the x power, it's going to give me a horizontal line. You're not going to see it because it's on the x-axis, with a hole at 0. So if I do second trace value and I type in an x of 1, I'm going to get the point 1, 0. If I do second trace, though, and a value of 0, I'm going to get a blank. 0 blank, because there's actually a hole there. Okay? So I know I'm talking about what the base has to be in terms of exponentials, but that's the same goes for the base of a log, because that, after you translate, truly is the base of an exponential expression. So base has to be greater than 0, but it also says base cannot equal 1. Why can the base not equal 1? Right, because this also is just a linear equation. This is just y equals 1. So it doesn't qualify as being an exponential. And similarly, if it was log base 1, it wouldn't qualify as being a log function. It doesn't have these general shapes. Okay? And then x has to be greater than 0 for the maybe obvious reason. Well, exponentials, the y had to be greater than 0. So for logs, which is the inverse, your x has to be greater than 0. We kind of already talked about it from the sense of the picture, but you cannot take the log of a negative. Log of a negative number, undefined. Log of 0, undefined. You can only take the log of positives, because you're going to take a positive number and raise it to something, it has to be positive. Even if you take a positive number and you raise it to negative 100, that's not going to be a negative number. What kind of a number, Nate, will that be? 5 to the negative 100. Positive, but how does the size of that exponent affect it in the fact that it's negative? It will be positive, but it will be, right, a teeny tiny one. Exactly. It'll be 1 over 5 to the 100th power. So even if we have a very big negative number, x always will be positive. It might be a teeny tiny positive, but it's still positive. So x always has to be positive. Okay? So really quickly, as a review from last year, we're just changing this to, if it's currently a log, we're going to exponential. If it's currently exponential, we're going to a log. This is a log, so what would that translate to, do you think, Mitch? 5 squared equals x, correct. In 6, or that's B, sorry, part B. Morgan, what log would this turn into? Log base what of what equals what? There's only a log on one side. We're going from this format, exponential, backwards. So let me ask you this. What's the base of the exponent? B. Whatever the base of the exponent is, that's the base of your log. So it's log base B. Now, I would definitely say going from log form, like what Mitch did in part A, is easier, Morgan. So I'm going to do that. I know I have this format. B is getting raised to what power? 3. So the 3 goes over here, and that equals what? 64. Does everyone see how I just did that? If you find exponential back to log is tough, I would say get your log structure there, whatever the base is, put that as your base, and then do that base raised to the other side equals the other number. And then part C, Sarah. Perfect. Any questions on any of those? Okay. Now we're evaluating all of these, which essentially means, what does it equal? And I like to say it equals x, because then I can just translate. 2 to the x equals 16, and you should be able to tell me that x is what, Bailey? 4. Did Mrs. Ziggy start these by calling it the what power function? Like 2 to what power gives you 16? Exactly, good. So maybe we can do these without doing that. 25 to what power gives you 5? Olivia. No, because to the 1/5 power means the 1/5 root. And we know, or means the 5th root, I should say. And the 5th root means what multiplies by itself 5 times to give you 25, and that's definitely not 5. 1/2. Very good. I was going to say, you're on the right track. Now, if you couldn't think that through, that's an easier example because of 5 and 25, and we're very familiar with those. If you couldn't think that through, you could change 25, get your common base, 5 squared, to the x equals 5. And then power to power means multiply, right? So 5 to the 2x equals 5 to the first. And then you can just set those exponents equal to each other now that there's the same base on both sides. If 2x equals 1, then x equals 1/2. If you couldn't do that in your head, which the tougher they get, the harder that will be. And then b to what power equals 1? Andrew? 0. Anything to the 0 power is 1. Unless b was 0, but we've already said b has to be greater than 0. Aiden? No, because that's part of the assumption. If you're taking a log and there's a variable as your base, the overarching rule, you don't have to say it every single time, no. Okay? Basic properties. What is log base b of b? People like to say they cancel, but it doesn't really cancel, because the question is the base of b to what power will give you b? Mitch? 1. In 2, the base of b to what power gives you 1? 0. b to what power will give you b to the x? B to what power will equal b to the x? X, right? B to the x equals b to the x. This one's trickier because this is technically in exponential form. Maybe you know what the answer is already. What would you say, Connor? B to the log base b of x. Olivia? It is going to be just x. B to a log base b. 7 raised to the log base 7 will just sort of cancel, and it's just x. Cancel is the wrong word. This technically, as is currently in this format. So the base needs to go to the base of a log. The exponent needs to go to the other side. So the b needs to go to the base of the log. The exponent, which is this entire thing, needs to go to the other side. And then whatever's over here is what would fill in the blank. So what would fill in the blank? It's a question mark. X, right? So it gives off the appearance that b to the log base b just cancels, and so your answer is just x. Okie doke? So those shortcuts. So right here, we're going to use some of these. Log base 4 of 4 to the 5th is just 5. Log base 9 of 9 is just 1. Bridget, what's 6 to the log base 6 of 9? Good. And log base 8 of 1, Nate? Go back to the other side, look at your 4 rules, and tell me which one applies to this case. Zero. Oops. Okie doke. All right. So here we're actually going to graph an exponential function and a log function and inverses on the same set of axes. I'm going to, maybe I'll hold off on the exponential. I'm just going to graph this. So my asymptote, as always, is the y-axis. X equals 0. And if I can't have an x of 0. So if I have an x of 1, 2 to what power gives me an x of 1? Does everyone see what I'm doing there? I'm making x, oh no, I'm making x1. Yeah. Log base 2 of 1. So 2 to what power gives me 1? 0. Then if x is 2, two to what power gives me 2? 1. Then if I were to do 3, 2 to what power gives you 3? Maybe I don't want to do 3, right? Because it's not something you're going to be able to do without a calculator. What would be the next domain element that I could do in my head, Joe? 4. So 2 to what power, Joe, gives you 4? 2. And so just knowing what we know about the structure here, it's going to do something like that. So let's answer this question. As x approaches 0 from the right, where's g of x going? What do you think? Marissa. Raise your hand if you agree. Olivia half raised her hand, Marissa, in your defense, and then she stopped because no one else did. Aiden agrees with you, and Olivia, do you agree, Olivia, or not? Olivia does. Bailey has now jumped on the bandwagon. Andrew is on the bandwagon. Am I missing anybody? So you've got 4 people in your corner, Marissa. Are you still in your corner? Who has a different thought? Connor? Connor's saying negative infinity. Raise your hand if you agree with Connor. He has 5 people in his corner. 6. Is anybody going to ditch Marissa? I should ask that question. Andrew, Connor, Aiden rather, Bailey. Where were you? Were you ditching Marissa? No. Aiden, was that a hand to ditch Marissa? Marissa, how do you feel about that? Are you? Or don't you know at all? You don't know. Aiden, why are you ditching Marissa? Be nice. Okay, so as your x coordinates are getting closer and closer to 0 coming from the right, your y coordinates are going towards negative infinity. Connor, nice job. How about this? As x approaches infinity, what's happening to our g of x values? Nate? They're going to infinity also. Raise your hand if you agree with Nate that they're going towards infinity also. Well, would you look at that? He's got a lot of support. He's correct. It does look like it flattens out, right? We can all agree it's certainly not going to be accelerating as quickly. But we also know, being a log function, there's no horizontal asymptote. There would have to be a horizontal asymptote if you were going to give a numerical answer. If it's not a horizontal asymptote, then it's got to be infinity or negative infinity. Okay? All right, so back to the parent graph features. The x-intercept is always... Bridget? Good. If b is greater than 1, the function is what? Increasing or decreasing? Increasing. Good. Same. These rules are the same as they are for exponentials. And if b is between 0 and 1, a fraction essentially, then it is decreasing.